you have to start at square 1, and for each move roll a 6-sided dice, right? So this is a dice, right? So there is each side has a mark 1 2 3 4 5 6. So when you roll this dice, you will get a number, right? Our goal is to reach the final square, means 36. You can say n square. The board can be converted into a graph. If let's suppose, so we'll move the dice can be any number will come, right? And so we'll move to any number. Let's suppose it come 2, it may become 3, from 2 it may come 5, like that. There is a possibility that we can move. So we can, what we can say that, so this problem is actually a graph traversal, right? But each node we can think like each square we can say like a node, and each dice rolls create an edge, right? Each dice can create as a you can say edge, right? And so the six nodes we have, so we can represent like this. And so we'll use this BFS traversal because it looks like a graph, and we can use the shortest path algorithm. So once we will convert the 2D into 1D array, right? So it will be easy for us to implement that. So how you can move the n square board into 1D array. So let's suppose this is called moves. So from n square board you can write n square plus 1, and you can move into the moves. The moves will be the array like a board. So this is the flatter board, we'll say, and we will first fill the value with the alternate left right and right left directions. So let's suppose we'll take moves. We'll initially will fill -1 -1 like that, and then 35 like that. There will be a possibility we'll do that, right? And when we flatter the board, right, so it will become easier, right? The traversal will be easier, right? So we can take a queue, or you can say we'll provide the first node, and then we mark it as a visited, right? So if the queue we have added the first one at the first, so we will mark the visited at 1 is already true, and then we'll move to the next one, right? Like that we know how to traverse the BFS. So we will do the BFS setup like you know that from the square 1 we have already start from the square 1, right? So we'll make a while loop. We'll say if it is not empty, the queue is not empty, but we added all the queue because we have started from the square 1. So queue is not empty, so we'll come to the for loop, right? So for square we'll take the its neighbor node, right? If neighbor node is not there, right, it should be there. So from the current, right, we'll get the next current plus I will do, and we'll get the next, because all the moves will be there and we'll have the I value. So each time we will get the next. How we'll find the destination? Moves at next should not be equal to -1. Then we'll go to the moves. Otherwise, we'll get the next. So for each move, we'll do the roll dice, and we'll jump through the ladder or snakes.